Today we're going to discuss distributors and electricity and condensers and points. And all my videos are prompted by either things I've encountered in the shop or questions I've been asked. And in the past month, I've been in a situation where I've had two condensers be bad. One I personally encountered, and another was a shop in Colorado Springs called up and described the same situation that I had been going through with what turned out to be a bad condenser on the distributor. And I told them what had happened to me, and sure enough, they also had experienced a bad condenser. So we're going to start off with what the condenser does. It sits off the side of the distributor and is connected to one part of the points. And what happens is when the distributor is rotating like this, the points open and close. And when they open, consider them as an electrical switch. When they're open, the electricity, path of electricity is interrupted. And what happens in that split second that they're open, the coil gets 12 volts from the battery, and inside the coil are a series of windings, a primary and a secondary winding. And what happens due to the amazing wizardry of physics, the coil builds up a huge amount of energy inside of it. 20 to 40, 60,000 volts, depends on the type of coil, but 20 to 40,000 volts. And that's when the points are open. The points close, they complete the circuit. That electrical field inside the coil collapses, and all that electricity comes streaming into the distributor cap at the top here, and then the rotor, which is spinning around, points to each of the terminals inside the cap and distributes the electricity. So if you have any questions about how much voltage there is in there, go ahead and start your engine and grab a spark plug lead and stick your finger in there, stick a wet finger in there, and see what it feels like to get shocked by 20,000 volts. It's a strange sensation. It's painful but survivable, and it's not the kind of electricity that's going to kill you. Anyway, so the points are an electrical switch. Now then, when they open, that electricity's got to go someplace. And when the points are open, the electricity that is not being used goes into the condenser. Condensers are very simple items. It's a series of wax paper and aluminum foil wound up, and it absorbs energy. And if it didn't, for instance, you can run your distributor without a condenser, but what happens is that extra electricity that's usually going in the condenser, that electricity is going to start arcing across here and burn your points out. So you can operate a car without a condenser, but not very long, until the points burn out. So, but strangely enough, some condensers go bad. I have no idea why, because there's no moving parts, and it's just a simple wound up spiral of aluminum foil and wax paper. But we're going to test our condensers to see if I'm going to show you how to test a condenser. Other people have showed this on YouTube, but we're going to show you. I'm going to explain to you why the condenser is important and what it does. So what we're going to do is we're going to have fun with our VOM. Anytime we get a chance to operate a VOM, we take it, because this is fun. So first thing people tell you to do is discharge any potential charge inside here by grounding out the condenser. I don't know if that's necessary, but they do that. Anyway, so we're going to go into the ohms section here. Go down to ohms at about 2K. And what we're going to do is we're going to charge the condenser. We're going to fill it full of energy from this 9-volt battery in here. Make good contact. And we should be charged. Now we're going to turn over to the DC. Let's go to the 2 volts. And what we're supposed to see is the electrical charge dissipate slowly. There we go. We're dissipating the charge in a uniform, slow manner. Pretty cool. Okay, that works. Now then, let's test a few others. That's a brand new condenser from Bosch. All these are being made in Turkey currently, and I've heard tell that some of these are not 100% functioning, but it's all we got right now. Even the ones from Mercedes are going to be made in Turkey because they're all getting them from Bosch. So I'm going to open up a condenser that hasn't seen the light of day in probably 30 years. You can see it's got the old part number on it. I've heard people say these things go bad sitting on the shelf. I don't know if that's accurate or not, but anyway. So what we're going to do right now, we've got it on the 2000 ohm scale. Let's put a charge into it. Now then, let's go over to the 2 volt scale and see what happens. There we go. It holds a charge and is discharging not as uniformly as the other one, as the brand new one, but it looks like it's a functioning condenser. Let's try one more. Let's see if we can find one that's off the shelf that's not working. Okay. And charging. Now I'm not even going to disconnect. I'm just going to go right over to the 2 volts scale and see what happens. Maybe it didn't like that. Let's try another. Let's do it. Let's go back and charge it. All right, now let's disconnect over to 2 volt and hit it. See what happens. Okay. Discharging. Appears to be working. Okay. So now then, another issue people have is, oh I know, I was going to test this one right here. This one came off of a car I'm working on now, and you can see it's seen better days. And see if how this one was working. This thing was really in tough shape. Visually, I don't know how it is electrically. We're going to find out. Looks like this one's working just fine. In fact, I think I'll stick it back on the car. It's discharging very nicely and in a uniform fashion. So I'm going to put that back on the car. We're going to discharge it here against itself. Put that back on the car. Now then, let's go on to points. Discussing points. Remember, these are an electrical switch, and oftentimes when people change points, they don't realize that you've got to have this part here is insulated. See, it's insulated right here, and it's got insulated block down here, and also insulated out here. So this post and this point right here are insulated from the rest of the distributor. It has to be insulated, otherwise it'll be shorted out. And the way you can tell if you have a problem, if you've changed your points and things are not working, real easy test. Put our contact right there. Go over here. And points are open. And I've got this on the, we're going to make, it's going to make a beeping noise. And you see we got contact. So that's how you can tell you've got your points installed correctly and insulated properly. Now let's go to this distributor, which came out of the car, had been sitting forever and a day. Okay, nothing. And you can tell by the way the points look, they are seriously oxidized. And so if these are oxidized, they cannot act as an electrical switch and work. So definitely want to check your points, not only for burning, but also for oxidation inside there. So clearly those points are not functioning. It could also be the condenser has gone to ground, and so you won't know until you change the points, and then if that doesn't work, then you go to the condenser. But as I've showed you here, even old grubby condensers are usually in pretty good condition, functional. Let's see, what else can we discuss? Make sure that on the distributor, make sure this plate moves. Your advanced plate is moving and returns. Don't forget there's a felt in here. You put a couple of drops of oil down inside here to lubricate the shaft. It's inside this hollow part right here. And of course you got your oiler right here. A couple of drops in there. A lot of people think that this groove is for a seal to keep oil from coming up here. That's not the case. That's for a dog point to go in there to keep the distributor from crawling up or moving upwards. Some distributors did have a seal on here, but that's not what this groove is for. So, anyway, fun with electricity. Hope that helps you out if you get in a bind sometime trying to make a car run after you've changed the points.